Hello children, how are you all and how is your study going on? I hope everything is fine. So here in this small video session I'm here to discuss two simple topics, two small topics of physics. Those are simply density and relative density. What is relative density and what is density you will know clearly. Relative density was previously called specific gravity. That term specific gravity is nowadays obsolete. Nowadays we make use of the term relative density. Okay, so these two are very small topics, but there are things to understand. Okay, so without wasting much time, let us give it a start. Yes, my name is Bapindas and you are watching your channel etuition, and I'm here to help you and guide you in your studies. Let us understand what is density. So before we understand the term, the quantity which is density, we need to know two more terms, two more physical quantities, which are mass and volume. Okay, what is mass? Which is denoted by A. Mass is actually the amount of matter or the amount of substance contained inside. Okay, amount of matter, contained inside, amount of matter contained in a body. And what is volume? Volume V is the space occupied by a body. Space occupied by a body. Okay, and now come to the definition of density. This is denoted by D or rho. D or rho, right? D or rho, these two are the symbols by which we denote this physical quantity, that is density, D or rho. Okay, so here we are making use of the symbol D. Okay, D is equal to m by v. Density is equal to mass by volume. Yes, that is the formula for density, and that is defined as mass per unit volume. You can easily understand by having a look at the formula. Mass per unit volume of a substance is called its density. Mass per unit volume. Mass per unit volume of a substance is called its density. Is called its density. Mass per unit volume of a substance, right? Volume has to be 1 unit, that is in Cgs system it is 1 centimeter cube, and in SI system it is 1 meter cube. All right, 1 unit volume. The mass of that 1 unit volume of any substance will be called its density. How to measure the mass? Mass is simply measured with a physical balance or beam balance. How to measure the volume? Volume is measured with a measuring cylinder or measuring beaker. These are the devices with which we measure the volume of irregular solids. For some regular solids having a regular shape and size, okay, out there like sphere, like a cube, like a cuboid, like a cylinder. Okay, so these are the things for which we make use of some specified formulas out there. With the help of the formulas we can easily calculate the volume of those regular solids, but for the irregular solids, we make use of a measuring cylinder, a measuring beaker, or a eureka can. So now, let us understand the SI unit of density. The SI unit of density is SI unit of density is SI unit of mass, that is kg, by SI unit of volume. Because have a look, in the formula for density is mass by volume, so in numerator should come the SI unit of mass, in denominator should come the SI unit of volume, which is meter cube. Meter into meter into meter, length into breadth into height, right? For a cuboid, cuboid is actually a standard shape which is used to find the unit for volume. Length into breadth into height is the formula for the volume of the cuboid. Okay, all the units for length, breadth and height are meters only. So meter into meter into meter is what gives you meter cube, right? So kg per meter cube, or kg meter to the power minus 3 is all we can write in the form of indices or exponents, right? That is the SI unit of density, kg per meter cube. And what should be the Cgs unit of density? Tell me. The Cgs unit of density is gram per centimeter cube, because you know the Cgs unit for mass is gram and the Cgs unit for volume is centimeter cube. Okay, so all you're getting is gram centimeter to the power minus 3. That is same as gram per centimeter cube. You know, somewhere it's written like gram per cc, gram per cc, gram per cc. What is cc? Cc is nothing but centimeter cube. Okay, it's the full form of cc is cubic centimeter, cubic centimeter, cubic centimeters, cubic centimeters. This is nothing but centimeter cube only. Okay, centimeter cube is said in this way also, cubic centimeters. So gram per cc is nothing but gram per centimeter cube, or gram centimeter to the power minus 3. This is the Cgs unit for density, and kg per meter cube or kg meter to the power minus 3 is your SI unit for density. Alright, so density, mass per unit volume of a substance. Based on the difference of densities, many kinds of differences or variations are found around us. Okay, just try to understand that what is cotton, a light substance, very light substance, right? What is iron? Very heavy substance, right? So is there a difference in density? Of course there is a drastic change in the value of densities between both the substances, cotton and iron, because you know, if you take 1 meter cube of cotton, okay, and if you take 1 meter cube of iron, what will have the more mass? Definitely iron. 1 meter cube of cotton and 1 meter cube of iron, both are having the same volumes, keep it in mind. Okay, I'm keeping the volumes same. Okay, what is density? D is equal to m by v, mass by volume, right? So if the volume is kept constant, if v is constant, what is constant? Constant means simply fixed. If the volume is kept constant, then d varies as m. What does that mean? The more is the mass, the more will be the density, right? If volume is kept constant, the more is the mass, the more will be the density. Now just remember the example which I just now told you. If you take 1 meter cube of cotton, 1 meter cube of cotton and 1 meter cube of iron, okay, I've kept the volume constant, keep it in mind. Volume has been kept constant. 1 meter cube is a volume, both cotton and iron, right? If the volume is kept constant, the more is the mass, the more will be the density. Which will have the more mass? Definitely iron, because iron is something heavy substance. From our common experience we all know that. So iron is having more mass, that means iron is having more value of density, greater value of density. Okay, so density for iron is greater than the density for cotton. Iron is a more dense substance than cotton. That is why the mass of an equal volume of iron is more than the mass of an equal volume of cotton. Okay, now the second case, if mass is kept constant, if the mass is kept constant actually, then what happens is density varies inversely as the volume. Density varies inversely as the volume, right? Now take another example. 1 kg of iron and 1 kg of cotton. 1 kg of iron and 1 kg of cotton. The mass has been kept fixed here, 1 kg, right? 1 kg of iron and 1 kg of cotton. So which will have more volume? Of course, cotton. 1 kg of cotton will have a big volume, a big lump of cotton, right? And 1 kg of iron is just a small piece of iron. Okay, what is the reason behind that? Reason behind that is density. Reason behind that is density. You got to know and understand from the previous example that density for iron is greater than density of cotton. That is why volume of iron is less than the volume of cotton. Is it clear? Because see, density is inversely proportional to volume. So the more is density, the less is volume, and vice versa. Density of iron is more, so the volume of iron is supposed to be less, because the mass has been kept constant here. Mass is constant, then density varies inversely as the volume. Is it clear? Is it making sense? The more is the volume, the less is density, and vice versa. See, 1 kg of iron will have a less volume than the 1 kg of cotton. 1 kg of iron will have a less volume because the density of iron is more than the density of cotton. Okay, so these are the two factors of density. First factor is density is directly proportional to the mass. Second factor, density is inversely proportional to the volume. Directly proportional means the more is mass, the more is density, and vice versa. If mass increases, then density also increases, and vice versa. If mass decreases, then the density also decreases. Second factor, density is inversely proportional to the volume. Inverse means the relation is reverse, the relation is opposite. When volume increases, then density decreases, and vice versa, right? When volume decreases, density also decreases. These are two factors of density. Now let's come to understand the relationship between the CGS and the SI units of density. I hope the concept is getting clear to you right now. Relation between the CGS and SI unit of density. Okay. SI unit of density and CGS unit of density. So let us start with the CGS unit of density. CGS unit, what is that? Gram per centimeter cube. Gram centimeter to the power -3 means 1 gram by 1 centimeter cube. Okay, what is 1 gram? 1 gram is actually 1 by 1000 kilogram. Okay, it is 1 centimeter cube. Remember, 1 centimeter cube is actually the volume of a cube whose each side is 1 centimeter. Yes, volume of a cube, okay, whose each side is 1 centimeter. Such a cube. Such a cube whose length is 1 centimeter, whose breadth is 1 centimeter, and whose height is 1 centimeter. The volume of such a cube whose length, breadth and height are 1 centimeter each is 1 centimeter cube, means actually 1 centimeter into 1 centimeter into 1 centimeter. So in order to convert this 1 centimeter into 1 centimeter cube into meter cube, we need to convert each of these 3 centimeters into meter unit. Alright, what is 1 centimeter in terms of meter? 1 by 100, isn't it? 1 by 100 meter into 1 by 100 meter into 1 by 100 meter. So all we are getting is 1 by 100 whole cube meter cube. Alright, that's what we can write here. 1 by 100 whole cube meter cube. Okay, now see, 1 by 1000 kg, in denominator you are getting 1 by 6 zeros over 1, because 100 whole cube, right? 100 into 100 into 100, so 6 zeros are coming, meter cube. Then 1 by 1000 into 10 to the power 6, or 6 zeros over 1, and the unit has been converted as kg per meter cube. Then 3 zeros are cancelled out, 3 zeros are still left. Okay, so we can write 1 gram per centimeter cube is equal to 1000 kg per meter cube. Yes, that is what the relation is. 1 gram per centimeter cube is equal to 1000 kg per meter cube. Alright. One gram per centimeter cube is equal to 1000 kg per meter cube, or you may also write 1 kg per meter cube is equal to 1 by 1000 gram per centimeter cube, or 10 to the power minus 3 gram per centimeter cube. Is it clear? So each of these relations are correct. Each of these relations are correct. This is very important, keeping in mind the examination, because you guys are asked to convert gram per centimeter cube into kg per meter cube and vice versa, and in examination you're asked to establish this relationship between the two units of density, SI to CGS and CGS to SI, and the relationship between SI and CGS units of density. I hope this is making sense. Keep it in mind that 1 gram per centimeter cube is greater than 1 kg per meter cube, isn't it? Right from the relation you can understand 1 gram per centimeter cube is equal to 1000 kg per meter cube, because 1 kg per meter cube is less, and such 1000 numbers of 1 kg per meter cube are comprising together to give you 1 single gram per meter cube, isn't it? So this is also important thing to keep in mind. Although this is looking like smaller, gram per centimeter cube, kg per meter cube, gram is much lesser than 1 kg, right? But still, gram per centimeter cube, the Cgs unit of density, is much greater than 1 kg per meter cube, when 1000 times greater than 1 kg per meter cube. Alright, because centimeter cube is there, right? Although the numerator is gram, is looking like smaller one, but in denominator it is centimeter cube and here is meter cube. That is why overall gram per centimeter cube is greater than kg per meter cube. Alright. Well, the next thing I would like to tell you is relative density. Relative density. Relative density, or RD. Okay. What is the definition of relative density? Simple kind of definition: density of a substance by density of water at 4 degrees Celsius. Density of water at 4 degrees Celsius. This is necessarily a number, because this is a ratio of two densities. Okay, numerator is density and denominator is density, so the units of density and density are cancelling each other, so relative density is necessarily a number, a pure number. RD being a ratio of two densities is a unitless number, is a unitless quantity It is a number. Okay, keep it in mind. RD has no Cgs unit or SI unit. Keep this thing in mind. Okay, now tell me, what is this density of a substance? Am I able to write? Mass of 1 centimeter cube of the substance divided by density of water, mass of 1 centimeter cube of water in Cgs system. If we take, because what is density? It literally is nothing but the mass per unit volume, isn't it? So unit volume is what I've taken in Cgs unit, 1 centimeter cube of volume, right? So if I multiply both numerator and denominator with V, the mass of V centimeter cube of the substance by mass of V centimeter cube of water. So the relative density can also be defined as the mass of a given volume of the substance by the mass of the same volume of water at 4 degrees Celsius. Is at 4 degrees Celsius is the one which should be included if we give the strictly correct definition of relative density. It may not have been given in your book, but this is the actual correct one, right? Keep it in mind. So we may define relative density also as a ratio of the mass of a given volume of the substance to the mass of an equal volume of water. Mass of an equal volume of water at 4 degrees Celsius. Alright. So from this kind of definition also, you may simply see that the numerator and denominator both are masses. So mass and mass, two units, same units of mass are cancelling each other. So in this case also, the relative density is coming out to be a ratio, a unit less quantity. Alright, keep it in mind. Now have a look at the thing that relative density in Cgs is equal to the density of a substance. Why? Numerical value I'm talking about of density, because you know in CGS RD equal to the numerical value of density. RD equal to the density, the numerical value. Okay, because you know RD equal to density of the substance by density of water at 4 degrees Celsius, which is 1 gram per centimeter cube. Okay, so if the density is expressed in Cgs unit, then the density of water will also come in Cgs unit, which is gram per centimeter cube. Okay, 1 gram per centimeter cube. So yes, gram per centimeter getting cancelled out to give you RD equal to D. RD equal to D, a density. Keep it in mind in Cgs system. Relative density and density both have the same values. But in SI, RD equal to density by 1000 numerical value. Why? Very simple, because you know RD equal to density in kg per meter cube. If it is, what is the density of water in SI system? 1000 kg per meter cube. Okay, kg per meter cube are getting cancelled in order to give you RD equal to D by 1000, or in other words you may write value, numerical value of density in SI is equal to RD multiplied by 1000. Yes, the density of water in SI is 1000 kg per meter cube, because you know 1 gram per centimeter cube is equal to 1000 kg per meter cube. is the relation between Cgs and SI unit of density, which I have shown you just some time ago, isn't it? So at 4 degrees C, at 4 degrees Celsius, density of water is 1 gram per centimeter cube, and that is same as 1000 kg per meter cube. Is it clear? That is why we say that in Cgs system the relative density and density both have the same values. Okay, you know the value of relative density, then you can just add the Cgs unit, gram per centimeter cube, with the same value to tell the density in Cgs system. But in SI system, Rd is equal to d by 1000, or in other words you may write, in SI system value of density equal to value of relative density multiplied by 1000. Okay, so if you know the value of relative density of a substance, then multiply it with 1000 to get the value of density in SI system, and you have to add kg per meter cube, the unit, along with that. Is it clear? So this is one important type of question which does come in examination, that prove that the Cgs value of density of a substance is same as the relative density of the substance, but the SI value of density of a substance is 1000 times the relative density of the substance. Okay, so a question like that is found to come in examination, quite an important one. From this concept you may explain, okay, and answer the question. Now I'm coming to solve a little bit of numericals on this topic, simpler ones, right? Simpler ones, which is of class 8 standard. Numericals. Some numericals. Given the density of air is 1.28 gram per liter, and you have been asked to express it in gram per centimeter cube, and number 2, kg per meter cube. Okay, this question is a really simple one. Gram per liter, 1.28 gram per liter. What does that mean? 1.28 gram by 1 liter. How much is 1 liter? 1000 centimeter cube. 1000 centimeter cube. Okay, so you're getting 0.00128 gram per centimeter cube. All right, and you know 0.00128 gram per centimeter cube is equal to, in order to get it into kg per meter cube, we need to multiply it with 1000. 0.00128 into 1000 kg per meter cube, that is 1.28 kg per meter cube. All right, given the density of alcohol is 600 kg per meter cube, express it into gram per centimeter cube. Express it in gram per centimeter cube. 6000 kg per meter cube is equal to 6000 divided by 1000, gram per centimeter cube, because gram per centimeter cube is equal to 1000 kg per meter cube, right? So 1 kg per meter cube is equal to 1 by 1000 gram per centimeter cube. So we need to divide with 1000. The answer is 6 gram per centimeter cube. You may also write it like 6 gram centimeter to the power minus 3. Okay, keep it in mind that gram centimeter to the power minus 3 is same as gram per centimeter cube, or kg meter to the power minus 3 is same as kg per meter cube. Okay, both of them are same. Either one of them, any one of them, you may feel free to use in examination anywhere and everywhere. All right, they don't make a difference. After 4, number 4, I want to do number 6. Piece of wood has mass 150 gram. I'm not copying the complete sum. Piece of wood is given here, mass is given, mass M is equal to 150 gram, and has a volume V is given also 200 centimeter cube. Okay, find the density of the wood in Cgs and in SI. Very simple kind of question. What should be its density? D is equal to M by V, right? So 150 divided by what? It's 200 gram centimeter to the power minus 3. That is 3 by 4 gram per centimeter cube, or 0.75 gram per centimeter cube. And if you have to convert this value into kg per meter cube, just multiply it with 1000. 0.75 into 1000 kg per meter cube, that is 750 kg per meter cube. All right, next I want to do number 9 here. Given mass of an empty density bottle is 21.8 gram, mass of empty density bottle plus mass of water equal to 41.8 gram, and mass of the empty density bottle plus mass of liquid is equal to 40.6 gram. Volume of density bottle, how to find? Mass of water, mass of an equal volume of water. Equal volume of density bottle of water is equal to 41.8 minus 20.8 gram equal to 21 gram, right? So what should be the volume? Volume is equal to mass by density. Volume of density bottle volume of density bottle equal to this mass by density of water, mass of water by density of water, 1 gram per centimeter cube, isn't it? Because the density of water is, as we know, 1 gram per cc. 21 gram into 1 centimeter cube by gram. This actually is 21 centimeter cube. I'm so sorry, the mass of empty density bottle was 21.8 gram. This should be 21.8 gram. This should be 20 gram, right? This should be 20 gram, and the answer should be 20 centimeter cube. Please make the corrections, rectifications. 20 centimeter cube is coming out to be the volume. 20 centimeter cube is same as 20 ml. Okay, is the answer given here is in ml. 1 ml equal to 1 centimeter cube. Keep it in mind. 1 ml equal to 1 centimeter cube. Both are basically the equal units, right? Not the same units, but equal units having equal values. In the second part of the question, they have asked the relative density of the liquid. What should be the relative density of the liquid? Relative density of the liquid is density of the liquid by density of water. Okay, density of water we know, density of the liquid we don't know. How to find the density of the liquid? The other way to find out the relative density of the liquid is mass of the liquid by mass of an equal volume of water, right? Mass of the liquid is all we can find out by subtracting 21.8 gram from 40.6 gram. See, mass of empty density bottle is 21.8 gram. Mass of empty density bottle plus mass of liquid equal to 40.6 gram. So if you subtract this 21.8 gram mass of empty bottle from the mass of empty bottle plus mass of liquid, you will end up getting the mass of the liquid, right? Mass of liquid, relative density of the liquid equal to mass of liquid by mass of an equal volume of water. Equal volume of water. That's what we have got already. Equal volume of water. Mass of liquid, how much? 40.6 minus 21.8. 40.6 minus 21.8 gram divided by mass of an equal volume of water. What was that? Is 20 gram. 20 gram. Okay. How much is that? Gram cancelled. 18.8 divided by 20.0. If we get rid of the points, 188 divided by 200. We cancel out with 2, 100 here, 94. So it is 0.94 as the answer is coming. 0.94. Yes, that is the answer. Next question number is 10. Okay, some data are given. Mass of empty bottle, that is density bottle, is equal to 22 gram. Mass of bottle, empty density bottle plus mass of water equal to 50 gram, right? And mass of empty density bottle plus brine solution equal to 54 gram, right? We need to find out the density and relative density of brine solution. Volume of brine solution is necessarily the volume of the density bottle, isn't it? Because the bottle has been filled with the brine solution afterwards, and first the bottle was empty and its mass is given. Afterwards the bottle had been filled with water. Its mass is given, combined mass of bottle plus mass of water. Okay, after that the bottle was filled with the brine solution. Brine solution means salt solution. Okay, salt solution is called the brine solution, same as that, keep it in mind. So what should be the mass of water, mass of an equal volume of water? Mass of an equal volume of water, what is that equal volume? Volume means volume of the density bottle, volume of density bottle, keep it in mind, equal to 50 minus 22, right? 50 minus 22, or 28 gram. 28 gram. Now tell me volume of density bottle. What should be the formula for volume? Volume of density bottle. Volume equal to mass by density. Mass by density. Mass of water is 28 gram. Density of water is 1 gram per centimeter cube. That is 28 centimeter cube, right? After that, find out the mass of brine solution. Have a look once again. Mass of empty bottle is 22 gram. Mass of empty bottle plus mass of brine solution is 54 gram. What should be the mass of brine solution? 54 minus 22, right? Mass of brine solution equal to 54 minus 22 gram, or 32 gram. What should be the density? Density of brine solution, mass by volume, right? So 32 by volume of brine solution is same as the volume of density bottle, because that was completely filled with brine solution. 32 by 28 gram per centimeter cube. 8 by 7, 1.14 gram per centimeter cube is what the answer is coming, the approximate answer, 1.14 gram per centimeter cube. All right, now what should be the relative density of brine solution? RD of brine solution equal to 1.14 only, because I've told you already that the value for relative density and the numerical value of density in Cgs system are same, right? Told you already. I have told you already. See, in Cgs system, RD equal to D, relative density is equal to the density, but in SI system, relative density equal to density by 1000, or density equal to relative density into 1000. These are so much important things, right, for doing this kind of numericals. Keep these things in mind, okay, so that your steps are shortened. Okay, so we will get it easier actually, the answer. So RD of brine solution is 1.14. because its density is 1.14 gram per centimeter cube, and this is Cgs unit. Cgs value of density. Rd is same as the Cgs value of density. Okay, just remove the units and write the numerical value, because the Rd is a unitless quantity. It doesn't have any unit. It is just a number being a ratio of two similar quantities, two densities or two masses. It is just a number, a unitless quantity. Okay, so that is your answer. Okay, so that's all for this session. This was just a small session as I thought it would be, but in doing these few numericals related to density and relative density, although very basic level numericals of the standard of class 7, 8. Okay, so in doing this numericals, this session has been little bit elongated. Okay, still I hope you could understand all the concepts and you will feel confident in solving this kind of numericals after you have understood this video session. All right, so keep on studying, keep on practicing. All the very best.